Hello everybody, welcome to my fourth Digital Systems 1 video. In this video, I will be covering Boolean Algebra. In this video, I'm just going to quickly cover what Boolean Algebra is. I'm going to introduce the notation, the order of precedence for simplification. Then we're going to go into some basic Boolean Algebra laws. And then after that, we're going to practice some simplification questions. So, first off, what is Boolean algebra? So, Boolean algebra it's a mathematical language. So, Boolean algebra is a mathematical language used to describe and simplify logical circuits. So, what is Boolean algebra? Boolean algebra is a mathematical language used to describe and simplify logical circuits. For example, I'll draw a simple logical circuit here. Just bear with me, guys. For example, this Boolean algebra expression right here is the same equivalent as drawing this circuit right here. It's just another way to describe a logical circuit. Okay? So what is the simple notation for Boolean algebra? So if you guys watched my previous video, you would know what an AND gate is, you would know what a NOT gate is, and you would know what an OR gate is. So in Boolean algebra, AB or A and B is going to represent our AND gate. A naught or a hat is going to represent our NOT gate, and A or B is going to represent our OR gate. Now, we'll cover this in more detail soon, but just remember that in Boolean algebra, the order of precedence is always brackets, then it's going to be our NOT gate, then it's going to be our AND gate, and then it's going to be our OR gate. Okay, guys, so now we're going to go into our Boolean laws or Boolean identity laws. So, the first law is called the identity law. And by the way, guys, when you are trying to get your Boolean algebra down and stuff, do not memorize these laws, if that makes sense. Like, as I write the laws, don't try to memorize them. The best way, in my opinion, to learn Boolean algebra is through intuition. And what I mean by intuition is that you want to just practice simplifying as much Boolean algebra expressions as you can, so you kind of just intuitively know the identity law, know the complement law, know the indompetent, and I think that's what it's called, idempotent and domination laws. You know the commutative laws, you know the distributive laws, you know De Morgan. Like, even though you might not be able to name it, you can just intuitively apply those laws to the situation. So once again, practice makes perfect. So first, the identity laws. Essentially, these both of these laws are going to leave our variable unchanged. So we're going to have x or 0 equals x, and we're going to have x and 1 equals x. You can think of it like x or false is not going to change anything, and an x and true is also not going to change anything. So that was our identity law. The second law I want you guys to know is our complement laws. So for our complement laws, x or x prime is going to equal 1. X and x prime is going to equal 0. X prime is going to equal x because these two primes are going to cancel out. Okay? Third law that you guys should know is the indompetent and domination laws. And I might be pronouncing that incorrectly, so bear with me. So, x or x is going to equal x. X and x is going to equal x. X or 1 is going to equal 1. X and 0 is going to equal 0. Okay? So, for our fourth law, we have the commutative and associative laws. So, for our commutative and associative laws, all this means is x or y is going to be the same as y or x, similar to addition. And also x and y is going to be the same as y and x. Okay? This also applies in other forms, like for example, x or y or z is going to be the same as x or y or z. So basically, the commutative and associative laws um, take precedence over brackets. Like, doesn't matter, right? So, for example, okay, fifth law, the distributive law. For the distributive law, if we have x and then y or z, so if we have x and ending the term of y or z, that is going to equal xy plus xz. Okay? Once again, this also does resemble ordinary algebra. The next portion we're going to cover is actually uniquely important to Boolean algebra. So it may feel unfamiliar, but if we have x plus yz, it's going to be x plus y, x plus z. Okay? And I'm going to just show you guys in reverse. I'm going to show you guys the factoring. So we have xy plus xz equals x y plus z. Because we factored out this x term out of this whole term, we're left with that. Okay, now I'm going to show you guys one of the most important Boolean algebra laws, It's called De Morgan's theorems. For De Morgan's theorems, if you have x or y prime, essentially what you're going to do is you are going to prime everything on the inside and flip the operation. For example, x prime, y prime. If we have x prime, if we have xy prime, it's going to be x prime plus, I can't draw the y, plus y prime. Okay? Um, for example, if we had x y prime prime, it would be x prime plus y. Okay? So we're just going to flip the flip the I guess you could say the order of the variable. So if it's x, it becomes x naught. If it's y, it becomes y naught. We're going to flip the operation because this is an and operation to an or operation. And then we're going to flip the outside not value. Okay? So it's kind of just like a flip. It's like a flip the switch, flip the switch, flip the switch. Okay? So to summarize, to simplify, to say the rule simply, you are going to complement each variable and switch or with and with or. Okay? These are going to be important later for implementing circuits with NAND or NOR implementations. That is something they asked a lot when I had taken this course. When I had took this course. Okay? So the law number 7, absorption. So, for the absorption laws, x or xy is going to equal x. These are also some laws that are different from algebra but unique to Boolean algebra. So x and then x plus y is also going to equal x. These laws you might have to memorize, to be honest. Okay? So, yeah. So, now that we've went through all 7 major Boolean algebra laws, now we are just going to go straight into simplifying Boolean algebra equations, which is also simplifying logical circuits. Just remember, whenever you're given a Boolean algebra equation, you always want to simplify it as much as possible because it leads to things being it lets I can't speak today. When you simplify Boolean algebra as much as possible, it makes implementing your logical circuit easier to draw, less complicated, and also this is something to think about later, but something that will probably be mentioned in your course is that it is actually cheaper to implement a circuit with fewer logic gates or the same types of logical gates. Okay? So now we're going to go into simplifying some Boolean algebra expressions. Okay, so for our first simplification question, using the laws of Boolean algebra, we are going to simplify this expression. So all of this is going to equal f. Okay? So first off, what we are going to do is we are going to group terms that differ in their value of a. So what I mean by that is, see how this term has a prime? we're going to group this A prime term with a term that is non-primed. And this A prime term with a term that's not primed, and this A prime term with a term that's not primed, if that makes sense. Okay, so it's going to look like, okay, that's what our first term is going to look like. Sorry, I meant to write the question like this. Okay, so this is what our first term is going to look like. This is what our second term is going to look like. And then this is what our third term is going to look like. Okay, so now that we have grouped these terms together, what we're going, so if you noticed, what we've done is we've grouped like A terms, but not just like A terms with B and C terms that we can then factor out, if that makes sense. So, for example, we have B prime C and B prime C that can be factored out. We have BC prime and BC prime that can be factored out. And we have BC and BC that can be factored out. So we are going to now factor those terms out of our brackets that we've made. Now, please note, like, even if you're not understanding this, man, you got to rep it out yourself. This comes with intuition. Okay. So now that we factored out B prime C, or B, now that we factored B prime C, BC prime, and BC, now we are going to use one of our Boolean algebra laws. We know that A prime plus A equals 1. Okay? So now it'll be B prime C 1 plus BC prime 1 plus BC 1. Okay? Now, remember, based on one of our Boolean algebra laws, we know that x and 1 equals x. So this will then simplify to B prime C plus BC prime plus BC equals F. Okay? So now that we have our term like this, if you noticed, we can factor B from these two final terms. So that's what we'll do. Okay, based on our Boolean algebra laws, we know that C prime plus C is going to equal 1. Okay, now remember, based on our Boolean algebra laws, we know that x and 1 equals x. So therefore, this will be B. Okay, now that we've done that, we're just going to reorganize this so you guys can see the commutative law I'm about to use. So using, well, I just used the commutative law to reorganize. Now I'm going to use the distributive law. So if you don't remember, it's x plus yz equals x plus y, x plus z. So for us, what that's going to look like is it's going to be b plus b prime, and then it's going to be b plus c equals f. Now, remember that b plus b prime is going to be 1, so it's going to be b plus c times 1 going to equal f. And then remember, x and 1 is x, so then therefore it'll be b plus c as our final answer. and simplification to this Boolean algebra expression. I hope you guys can see the importance of Boolean algebra simplification, because imagine the prophet asked you to implement, like, imagine the prophet asked you to implement this circuit and draw it, and you had not simplified it beforehand. You could have just drew this. You know what I'm saying? You literally could have just drew this, and you would have had a great time. Okay, so we're going to go into our next example. Okay, guys, so for the next Boolean algebra expression that we are going to simplify, we have a and b all prime plus a prime b plus a prime c. So first for this, we're going to apply De Morgan's theorem, which means that we are going to flip the operation and the value of the variable, whether it's prime or not. So let's apply our De Morgan. Okay, now that we have this, if you see that there's a common factor among each literal, so then we are going to factor out a prime. If you guys had seen that, if you got, well, I'm about to explain it, but if you guys caught that, we have b prime plus b here, which we know will simplify down to 1. Now, based on one of our Boolean algebra laws, 1 plus x equals 1. So this is going to be 1, and then we know that based on one of our laws, okay, so we know that our value is going to be a prime for this. Okay, now I'm just going to do one more Boolean algebra simplification question, and yeah. Hello, so we'll be doing our third and final Boolean algebra simplification question. So right now we have a or b and a or b prime and a and c, or a and c. So what we're going to do, the first Boolean algebra law we're going to apply here is we are going to apply our, remember, this law. So for this law, it's going to be a plus b, b prime. Whenever you see a in both brackets and you see it's being ORed with two different variables, you know that you can convert it into this form, or vice versa. So we know that b and b prime is going to equal 0. Okay, so we know that a or 0 equals a. So a plus ac. We know that using our absorption law, which is x plus xy equals x, that we can actually absorb this c value. So our answer is A. So that was Boolean algebra. That was some laws. That was some practice questions. I hope you guys enjoyed. I hope I helped your understanding of Boolean algebra. If you guys have any questions, constructive criticisms, etc., please don't hesitate to reach out to me on my Instagram. And I hope you guys enjoy the rest of your day.